everybody knows, the whole New Orleans area is built in a saucer. All of the flows that fall, all the rainfalls that fall on New Orleans are trapped in that saucer and have to be mechanically pumped out.
The city is surrounded by levees, so every drop of water that comes into the city by any means, by rainwater or by infiltration under the Mississippi River levee or infiltration through the sand stratas from Lake Pontchartrain, has to be lifted out.
So it requires pumping stations of very large capacities.
We're built on a swamp, and the soil dries out, and it doesn't subside as much as it decomposes. When the city subsides, it increases the problems.
Jefferson Parish is located below sea level. Our elevations varies from 4 feet below sea level to almost sea level. The general topography of this area. So all the runoff through a network of canals, it ends up to lakefront, which we have our major pump stations.
And they have to evacuate it through a system of canals. The street systems in this area are dictated greatly by the arrangement of the canals.
We have a system of drainage, which is a relatively old system. And most of our old subsurface drainage system have been designed for a 2-year storm frequency, although our canal systems are designed for a 10-year frequency.
We have stations here that are capable of pumping several million gallons of water a minute in order to evacuate the water. And there are many stations in the area with that capacity.
In the east bank of Jefferson Parish, we have 5 major pump stations. On the west bank of the Jefferson Parish, we have about 14 major pump stations.
Size and capacity of the pumps dictate the size of the station. Also, the total pumping capacity that is desired based on the drainage area that the pumping station is going to serve. First, we develop a preliminary plan for the layout of the station and the discharge basin, the intake basin. And based on the theoretical layout, we provide these plans to an independent model testing laboratory, who then constructs a model to maybe 1/10 or 1/9 the size, and they give us the test to see if our design is hydraulically efficient, because if it isn't efficient, you can lose 5 or 6 feet of head, which in terms of horsepower and expense over 30, 40 years or 50 years, the life expectancy of the station, could add up considerably.
We went in and modeled every station that we made an improvement on. And we found out that the theory back at the turn of the century was, if you want to pump more water, you put in more pumps. Well, that's not necessarily efficient, because some of the pumps were fighting each other. And by making an authentic model of the station, we were able to find things like vortices being developed on the floors of the stations by merely putting in small walls in some of the stations. We've been able to improve the stations by 1 or 2 pumps sometime. Right now, this station is so efficient, the canal that supplies it is inadequate. We have to more than double the size of the canal coming into the station to get the water to the station.
Once a pump is selected, it's up to the manufacturer to furnish a pump that meets the engineer's design criteria, both for the head conditions and the CFS capacity it's supposed to deliver. Basically, the pump manufacturer will submit to the engineer a series of design drawings and submittals, at which time the engineer reviews, makes comments, and it's up to the manufacturer to answer and address all questions.
Well, you're concerned about pumping capacity and the development of them, and also the maintenance, the operation and maintenance of the stations, and the longevity of the stations.
Our concerns are the getting the flows to the pumps, keeping the trash out, easily maintained by Jefferson Parish personnel. These pumps are 11 foot in diameter and cannot be shipped whole, so they come in a number of pieces. All of these pieces have to be aligned, fitted, and assembled. The manufacturer provides an erection engineer who has all of the technical knowledge to assist the engineer and the contractor to assemble these pumps. As you can see by their size, they can't be taken in and out for repair, so the design and manufacture of the pump requires that they be built to last a lifetime.
The vertical pumps have a pumping capacity in the area of 135,000 gallons of water a minute, and they run 320 RPM. The horizontal pumps, which are the high volume pumps, have a capacity in the area of 500,000 gallons of water a minute, and they run at a mere 105 revolutions per minute.
Our major pump stations, their capacities varies from 5,000 to 3,000 CFS. The rotating assembly of these pumps are installed above the water level, and therefore they are protected from rusting. And the pumps are very versatile, and all pumps are driven by engines. And so in essence we can say that they are variable speed pumps, since we can change the speed of the engines.
This is a cutaway of a typical Jefferson Parish pump station using horizontal pumps. This is a suction canal which feeds the water to the pumps. We go through a series of bar screens which prevent trash from entering the pumps, under the trash bridge, through the beginning of the suction tube and into the pump itself, which here we have the impeller and the diffuser, which lifts the water and steers it through the discharge tubes. Here we have the high point of the discharge and prevents water from coming back through the discharge tube. Downhill through the discharge structure onto the slab, which prevents erosion in the bottom of the lake and out into Lake Pontchartrain.
The impeller is approximately 11 feet in diameter. The weight of the rotating assembly which consists of the impeller, the shaft, and the bearings is over 50,000 pounds. It's quite a massive piece of steel. The discharge end of a horizontal split case pump used for flood control. The pump is 11 feet in diameter, and I'm here next to the diffuser of the pump, and Billy is down at the end where the impeller is on the suction end of the pump.
It's an 11-foot diameter, four-bladed impeller which is capable of propelling about 1,050 CFS water at 100 RPMs.
And once the water leaves the impeller, it is pushed through the diffuser. The function of the diffuser is as a flow straightening device. It smooths out the discharge of the water through the discharge tube. Once the water leaves the tube, it goes into Lake Pontchartrain.
These pumps move a lot of water at low head conditions. They're very efficient, they're easy to operate, and they're also very easy to maintain because they're high and dry when they're not being used.
The drive mechanisms, the pumps themselves are always above water, where your vertical pumps, the lower bearings, the impeller would be always submerged in the water, harder to get to. With these pumps, they can be maintained in a dry condition.
We have, I guess, about 28 of them in the system, and we've only taken the cover off of one of them. And the first large ones were put in back in 1912.
On an annual basis, our pumps, they run anywhere from 50 to 100 hours a year. Although in some wet years, we've had up to 200 hours a year.
Total pumping capacity is around 42,000 cubic feet per second, and we can pump 25 billion gallons a day, or a little over 1 billion gallons an hour during a rain load. And we often do that. It's not unusual that we'd have a full house at almost every station in the system.
If a pump goes down, it could be catastrophic as far as house flooding, street flooding, and so on. Most of these stations have redundant ancillary equipment to ensure that that pump will run, either doing power loss or loss of cooling waters and so on.
This particular station that we're standing in right now is dedicated to the AC supplied equipment. We provided the 5 pumps, 3 gearboxes, and 3 diesel engines, 2 electric motors for this station, and all the controls for that equipment. Right now, by having all the equipment supplied by one company, it allows us to package the equipment supplied by other corporations, other businesses, to fulfill the need of the community. We're at the new Estelle pumping station on the west bank of the Mississippi River. This pumping station was a combined effort between Jefferson Parish and ITT AC Pump, using AC pumps along with gearboxes that we provided, and coupled them to engines that were owned by the parish. So it was a sizing effort between the parish and AC Pump. The capabilities to provide that kind of design is our specialty. Every pump that we manufacture is custom made. Each pump meets specific hydraulic needs that that station requires. And in this particular one here, we have pumps that are moving 600 cubic feet per second.
AC Pump has supplied all the existing equipment that's been installed in Jefferson Parish to date, and they have the contract for the future pumps, and they have a very knowledgeable technical staff. They've always been there if we've had any questions concerning the pump design.
They come down and work with you when you're installing the pumps after the manufacturing is completed. They supervise the installation, answer any assembly problems, and address all questions. These pumps are built with top quality material and craftsmanship, and are engineered for life.